Yeah, g'day. Mark here, and welcome back to my channel. Now, I've done 3 videos on getting this tool changer working for my CNC lathe. So now it's time I complete this trilogy with a video on getting it tied into LunixCNC and getting the thing working, changing tools automatically. And for that, I'm going to need a software component to do all the internal sequencing, and then what's called a HAL component to connect those signals from internal software out to the physical switches, pins, feedback, that sort of stuff. And I'm a pretty crap programmer, so I'm going to need some help. Since I've now hooked up both the pneumatics and the electrics of that tool changer, now I just need some software to make it do what it's supposed to do when it's supposed to do it. Now LunixCNC's got a tool table, and then you give every tool a tool number and can also tell it which pocket it's in. For this case, I'm going to just use the pockets 1, 2, 3 and 4 to be the positions on the tool changer. And I can even have different tools on the same pocket and they'll just get different offsets. You call a tool with the G-code command, T for tool number, M6 for tool change, G43 for load its offsets. I need LunixCNC to know that whenever a tool change is called, it has to play around with my turret. Both with coding and with LunixCNC, I consider myself a medium advanced beginner. I know sort of enough to have a rough idea of how to do things and to try things, but not really enough knowledge to really get myself out of trouble. Now, in my last Schaublin video, I'd left us needing to update my LunixCNC build. I did that, bit of mucking around, I made a few mistakes, but I finally got the thing all up and working. But before I can start working on that software component, I got a visitor. So today visiting me is Christian. He's local, met him through the channel. So Christian, what's your interest in machining?
Well, I'm mostly interested in making stuff for optics and building cameras and everything that goes with that. So right now I'm building a thread milling spindle for my mini lathe, and Mark is helping me.
So as you can see, that Christian didn't just bring work, he also brought a couple of gifts from when he was last in Japan. So thank you very much, Christian. But let's take a look at your spindle.
Thread milling spindle, it's intended for being mounted to the lathe. For that, I made this holder. Today we are planning on making that mount from PLA into steel. And for that, I've prepared the blank of the holder. And now we're going to bore it out, then weld it.
So this spindle is feeling extremely smooth. I'm seeing you made it from an ER collet chuck. What sort of bearings did you put in it?
The first ones are regular bearings and then a pair of angular contact bearings.
Nice. Now it's feeling beautiful. And the main use is going to be thread milling those super fine threads for camera screw attachments and stuff,
so
right?
I think the largest will be 1mm threads for M42 and everything smaller than that. I've ordered some 60-degree and 55-degree single tooth thread mills, and then we will see how this works out.
Christian's lathe is one size up from the mini lathe, so I'll bore this out on the Schaublin because it's a bit easier to do it on a big lathe than on a small one, especially when you get to the bigger drill sizes. In this case, we're going to use a 25mm drill, but we'll drill it half in from each side. So our last lathe operation is just going to be to bore it out from 25, 26, which it is now, out to 30mm. The long skinny boring bar sure complained a lot, but it got the job done. Christian will be doing a final boring on this on his lathe once it's welded. Right, let's just spot this together. Christian did such a beautiful job of machining this curve that it fixtures like perfectly with just a tie wrap. Nice work. I stopped too soon, and man did I wander everywhere, huh? Well, you really notice you're right on the edge of this welder's capacity with heat and stuff. Oh wow.
Nice.
Pretty satisfied with those welds. They're not too bad. I put 3 layers on that side. Did it with just 2 on this side. Next we'll give it an hour in the oven at just under 600 degrees. Right, well before it goes into the heat treatment oven for stress relief of the welds, I'll just put some of this corrosion resistant or antioxidant snot on it, just to try and prevent the main body from getting all oxidized and damaged. I don't have to bother about the ends of it because they're going to get shortened anyway. It's a couple of millimeters over length at the moment. Okay, it's now a couple of days later. I've done the whatever the heat treatment is just to remove the stress, and it's looking pretty black. But hopefully this should come off quite easily with a bit of wire brushing. And with that, Christian finished the rest of this project in his shop, and he made a video about it. So I'll leave a link up here in the top right and also down in the comments section below. So go and check it out. Give Christian's channel a bit of love. Also on Instagram, he's pretty active there with all his photography stuff. Go and check it out. While turning those parts for Christian, I found I had a bit of an issue with my display. It's a standard 1080p display, and it's running through an HDMI cable. The screen works perfectly in all normal programs. I've identified no issues with scaling or anything. When we launch LunixCNC, you can see here it's starting normally. I've got it set for 1920 1080. This is looking totally normal. It's perfectly scaled to fit the screen. The right hand side buttons don't cause any scaling issues. Switching across to the tool table, it comes up fine. It hasn't rescaled yet, but look when we return. The whole screen gets bigger. It moves both in width and in height. If I do that again, I can't even get to the button anymore. So if I go to the settings and change to start maximized, hasn't helped. It's still scaled too big. I can now at least pull it around to see side to side. I can't pull it any higher. I tried machining with this. It drove me nuts. It very quickly became unusable. All I could do was just close it down and then restart LunixCNC. So it turns out that that weird scaling behavior was tied up with lathe macros. It just gives you a really nice and fast way of setting up standard toolpaths, which on a lathe is super handy. Now, unfortunately, it was something about them that was causing those scaling issues. So one of the developers, Hans, gave me the feedback to switch embed tab location over to user tabs. That puts the lathe macros, instead of being on a separate tab up the top, right up here, it puts them onto this button. I can go in and out of that screen without it screwing up the size of the main screen. However, as it is at the moment, I lose the DRO feedback. So it's not perfect, but at least it's usable like this for now. I've seen on the GitHub for LunixCNC that Andy, who wrote this lathe macro, and Hans, who's another one of the developers, have been working on trying to fix the behavior of the lathe macros. And with the scaling fixed, I can switch my attention back to the tool changer. Now there is a standard software component for controlling similar kinds of lathe tool holders. It's called Carousel. It was written by one of LunixCNC's real experts, Andy Pugh. I'll leave a link to his channel here. The problem is that RotarySMP is really written more for more modern tool changers, which tend to be positioned using either a stepper motor or a servo motor or something electrical like that. Talking with Trilobite, a gentleman who's also already converted the same lathe as mine with the same tool changer or very similar, one of the problems is that his one has 4 micro switches to show the 4 tool locations, and those micro switches, Cam must close them once they reach position. So he can use that as the feedback that the thing's rotated for long enough with the air pressure, and it can now drop down onto its locking mechanism. Whereas with mine, with Hall sensors, it rotates to a stop, but until you drop it down, the magnets don't get close enough to the Hall sensor to trigger them. Now, we did have a bit of a chat about that. Maybe I could add stronger magnets or something, but I really don't want to get in and change that stuff. I decided I'll have a go at trying to do the software myself. So after a couple of weeks of false starts and procrastination, I finally turned to AI. In this case, ChatGPT. I know it's good at coding, and I think the biggest benefit is likely to be that it knows all of the best methodologies and functions and stuff in coding, the sort of stuff that I just never learned. So I wrote out a set of requirements, tried to describe as accurately as I could what I know about this tool changer and what it's supposed to do. And I must say, the initial summary from ChatGPT was pretty good. It described really accurately what this component should do and roughly and how it should work. It only took me a couple of prompts, updates to get some code which, as well as I could understand it, looked pretty promising. So then I could get the code to compile. That was looking okay. Now I need to connect that software to the rest of LunixCNC, kind of wire it in. LunixCNC has a system called the HAL, the hardware extraction layer, and it's effectively virtual wiring. The interesting thing here, when I got ChatGPT to give me a draft of this virtual wiring, it had added a lot of the logic into the HAL using OR gates, AND gates, edges, things like this. And so I was starting to work with this and trying to get it going. When I came across, it was using a comparator to compare actual turret position with commanded turret position to work out if they're the same, I don't need to change. And it used a standard LunixCNC component called CMP2, comparator 2. Well, it was throwing errors, so I went looking, and sure enough, this doesn't actually exist. Here was a good example of AI hallucinating some component which it's not a thing. There's something similar, it's called comp. So on the one hand, using ChatGPT for this was a very positive experience because it provided a sort of a software framework and a set of functions that I wouldn't have used. For example, it used the switch case methodology, which I'd never heard of before, but it made for a very nice, compact way of working with this state machine. If you use AI in your normal world and just ask questions and accept the answers, are they really correct? I think using it for software is a good example of getting that clear feedback. Okay, you gave me something, it doesn't work. Investigate why it doesn't work. You just made up rubbish. So after a lot of debugging, a lot of mucking around, scratching my head, searching forums, searching the internet, getting help from a lot of very helpful people on the LunixCNC forum, I've got to this point. T3, M6, tool change. Give it some air. So the good news, everything's connected up. I had to play around with the timing a little because sometimes it would get stuck half turn. That seems to be okay with the timing now. However, it can't count. I know I've got an offset of 1. The software is counting from 0, whereas this is counting from 1. So good news, it's kind of working, sort of. Bad news, it can't count. So let's work on the counting. But first, let's do that one more time because it's kind of cool. T4, M6. Kind of seems like regardless of what I tell it to do, it just does 1 lap. Which, given the amount of effort it's taken to reach this point, a couple of victory laps is kind of cool. In the end, the final code took a little bit more bug smashing, just working with the timing really. Like we had triggering the tool change off an edge. It was only visible to LunixCNC for a single count. It took a few iterations of describing the specific error cases I was seeing. Okay, I think I've finally got a configuration that now works. I'll just put the air on. So we're currently on tool number 1. So let's switch to tool 11 and it should automatically move to pocket 2. Tool 11, M6. Let's do a jump over to tool 12, pocket 4. Switching to tool 22. Okay, now let's go to tool 1. All right, that's looking great. So the next thing I want to do is actually make a part. I've still got to do a bit of mechanical modification to work out why this slightly overturns and then gets forced back into its teeth. But I want to try one part first. So what I'm going to do is just go through and touch off all the tools, update their offsets in the tool table, and then I can start writing a program that uses all these tools. You might remember in my video where I received my surface grinder from Malta, my mate Luke had sent a whole bunch of half-finished wheel hubs, which just need finish machining. And I've managed to procrastinate on that job long enough that it's time to get into it. So I currently own 3 wheel hubs, and they're all different. This one's got balance weights on the nut, nothing on the back. This one's got no balance weights. And this one, it's got the balance weights kind of hidden in the back in the sort of dust protected area. This also has a part number on it, so I'm pretty sure that's original. So with a part number on the hub and also on the nut, I'm going to assume that this was the original. And even if it wasn't the original, having the balance weights protected from dust on the back, sort of down up inside this area, makes sense to us as well. So this is the one we're going to copy. Now these threads should be 1¼ inch by 16. Nope, no, it's much finer than that. What else we got? 18. Nope. 19. Nope. Okay, 1¼ inch by 20 there. I think what I'll do is clamp the blank on the outside, face it, make this relieved section, bore out the hole and thread it, and that'll be the end of the first setup. I just need to switch out my chucks. Because I want to see if I can do this next job using my pneumatic chuck. I made a video about this automatic chuck, I'll leave a link. It gets actuated by the collet closer, which is pneumatic. Now I just need to turn these soft jaws out a bit. At the moment they're at about 72 millimeters, but I think I need to take them up to about 90. that turned once, I wasn't tight enough on it, obviously. Let's now switch this over to my second toolpath, facing and turning, and let's go. Well, that didn't go too badly. Quite happy with that. Well, that pitch is obviously wrong. That should be 20 TPI, but it's way coarser. Let's take a look. So what have I got here? Oh wait, pitch 1.75, that's wrong. Should be pitch 1.27 for 20 TPI, shouldn't it? Okay, it's still tight. Let me just open it up a little. Throughout this project, I had challenges with the internal threading inserts. I think I got some pretty low quality inserts there because they really chipped out or wore out really fast. I tried playing around with different depths of cut and different speeds, but they wore. I ended up needing to do a roughing pass with an insert wore out and then a cleanup pass with a new insert on every single nut. Right, well I'm not even halfway through these parts and I've just run into a spindle problem. In high speed I've got no torque, trying to take a 1mm cut stalled out on the part, which was working fine before. And if I try to increase the speed with the variator, it starts to change but then stops. Going down is ignored. Going up it tries to make a move but stops. I sort of get the impression that the belt is slipping, the variator belt, but also that the variator is sitting on an end stop or behaving badly there. So I've already done my standard initial troubleshooting steps, which were turn it off, wander off, do something else, hope it fixes itself. As usual, that wasn't the solution, so now I have to do something a little more intensive. So I've got a speed increase and a speed decrease physical button. And a 24 volt signal comes out of here, either the plus or minus contactors, to send 400 volt AC down to the little motor which adjusts the position of the variator. If the spindle's not on, the signal gets ignored. There's also a spindle turning faster than 5 RPM. So if I turn the spindle, you can see that that now comes on, so that even if the spindle's commanded on, if it's not actually turning, the variator would still be inhibited because you can only adjust the variator with the spindle running. And then this is just a timer here. So whenever I push the button, it gives me 1 second of adjustment on the variator sheaths. That has been working totally normally. It's worked on the first 6 parts and now it's stopped working. Okay, so these are my 2 variator relays, and the end stop switches for both high and low speed feed through the auxiliary contacts of the opposite contactor to the coil so that they're locked out from each other, and also an end stop shuts them down. But this looks kind of weird to me. Not sure why this contactor is cycling at all if that contactor is commanded. And in the other direction, commanding results in nothing. Man, I'm so glad I made schematics. So from Earth, I should not have continuity on pin 1, which is the high speed end stop of the variator, or okay, so I'm on the low speed stop of the variator. Right, so at this point I'm going to do a prediction. And my prediction is that when I was rewiring stuff earlier, I by mistake switched over, so the low speed end stop is now inhibiting the high speed contactor and vice versa, which is of course back to front. When I recently added the second I/O card here, the variator drive signals got repositioned from that board onto this board. So that's a good place to start looking, following that wiring through and seeing if I got these 2 contactors cross-wired in some way. When I pushed the button before, the 1K5 closed and started to move, but then stopped. This is the electrical interlock to stop them both running at the same time. I need 1K4 to be off to get current through to the coil of 1K5. I should have a direct connection from pin 21 through to 1K4 61. Aha. Yep, I think I've got those 2 reversed. So that signal comes through here. From here, they should cross over to say you've got the inhibit going onto the coil. Yeah, that's correct. And this should be the same in the other direction. Yeah. So I think these 2 are just reversed. From A1, we need to go to pin 17. So this is correct. 17 connects to 1K5, 18 connects to 1K4. So the only thing I have to switch over are these 2 wires. Right, let's just check to see if that was the issue. Okay, looks like there might be more to it than I thought. As soon as I turn the main power on, that contactor pulled in. So that means its coil must be getting 24 volts even when there's nothing coming from the Mesa card. So I've just disconnected this output from the Mesa card. So why am I getting power at this point as soon as I turn the machine on? That pin shouldn't initialize with 24 volts. Let me just check that. Here's my earth. Yeah, 24 volts coming down that pin. It must have blown the output on this one pin, huh? Wonder how I did that. Well, having a look, I don't see any obvious damage to that driver IC. I mean, this Mesa card has definitely had a hard life. This used to be in my Maho milling machine, but because I had an intermittent contact in the main power plug, I ended up blowing the logic brains out of it, and Peter, Taylor 83, repaired it for me. I'm guessing that with my miswiring here, I've blown that one output lane. I'll try moving this onto a different lane and adjusting my firmware to match it and see if it then works. Okay, I just realized I actually had a second line reverse, and that's this one here as well, because I had the low speed end stop inhibiting the high speed line. So I'm going to need to redo the marking on them and a couple of others. But let's test it out. I'll screen increase the speed. Oh, now I've got that same behavior again. Oh darn. So it's sped up fine, but coming back down, it's not working. It's gone back all the way down to the bottom, to the end stop again. The contact is not currently in. Right, well, I've just disconnected that line from the I/O card again. Because it's disconnected, it should show 0 volts. But it's again showing 24. So it looks like I've blown another output channel because I already blew this one. So I better stop just moving it over and trying things, because otherwise I'm going to destroy this card completely again. So what's causing that card to blow? It supplies 24 volts when switched to the coils of this relay here, of this contactor. According to its data sheet, that coil's got a load of about 3.2 watts, which at 24 volts should calculate to about 180 ohms, so we're a bit low. Let's just compare it with, I've got a couple of other identical ones here. Okay, that one's also 150. 154. So the contactor that's causing a problem is slightly low on its coil resistance, but not so hugely that you'd expect it to be a short circuit or anything. Plus that Mesa card's supposed to have short circuit protection and protect itself and fault out. Well, after troubleshooting the blown output channels of the 7i84 card, I got a bit frustrated. Didn't really have much of an idea of what I should do next for troubleshooting. So I wrote all the symptoms up and sent them to Peter, Taylor83, who repaired that card for me last time I blew it up. And then I slept on it. And I guess that action of writing up all the symptoms and my thoughts was a pretty good example of rubber ducky troubleshooting, because today I realized there's nothing in that circuit other than the coil that could cause the excessive voltage. So by the time Peter got back to me, I'd already sort of thought through and realized, hey, this could be a case where I need flyback diodes. There's a saying in German, wer lesen kann ist ein Vorteil, and this is a good example. Like, if you can read, it's probably an advantage, because it actually says black and white in the Mesa 7i84 manual in bold letters that if your coils exceed 60 milliamps, you should put flyback diodes. Well, these are a bit over twice that. So, okay, learned something there. Anyway, got home from work, came down and had a look at it and realized, wait a minute, these have already got some sort of a surge compressor, snubber, flyback diode or something on them. Now from the graphic printed on it, this snubber seems to have diodes facing in both directions, which I don't really understand. Although it does show polarity, plus to minus. So my next thought was maybe I wired these wrong and I've got the power coming out of the 7i83 coming into coil terminal A2, so the negative side, and coming out at A1. But nope, check the wiring, that's not the case. The positive is coming in at A1, so that's not the problem. I guess I can do a diode check on this and just see if it's burnt through or something. I'll compare it with its mate. So, diode function. I got negatives this side, positive this side. Okay, that's showing nothing. Other way around. Also nothing. What about the other one? Nothing, nothing. Nothing, nothing. Okay. So that doesn't really tell me anything. Wonder why these show two diodes facing away from each other. To me that would mean it's just nothing. I've also seen in the catalog there's another one of these with a part number 1DG00. It just has a single diode like I would have expected. So I wonder if I've got the wrong module for this application. And the other suggestion from Peter was I only drive little coupling relays from these outputs and use the coupling relays to drive the coils of the contactors, which, considering that I recently removed coupling relays and put in the second 7i84 card, it looks like maybe I did what's in German a Verschlimmbessern. I broke it through improvement. If that's the only solution, I'm really short of space. I guess I could pull out this relay, which is currently unused. That's the three-phase relay that's here to drive the coolant pump, because the lathe does have a complete installed coolant system, and all I'd need to do is connect it up and use it. I've also got a circuit protection in preparation for that coolant pump. I guess I could maybe drop that out, put coupling relays in here. The only other place I could put coupling relays would be in the space between the two motor drivers, which I left free for airflow. Mail time. This is the stuff I spray between the mill table and the vise just to stop things getting rusty. Since I ground all my end mills down and they're no longer nominal diameter, I grabbed a couple more end mills because at the moment, man, the price of carbide is going crazy, isn't it? Figured if I buy a couple of end mills, hold on to them for a couple of weeks, I'll be rich. Aha, replacement hinges for my SK punch grinder box. It's much better. And since I had so much trouble seeing what I was doing last week with my tool grinding, I thought I'd try out some of these things. These are these little funky sort of look like night vision goggles but without the night vision. I decided to buy this set because it's got a bunch of different magnification lenses and I really wasn't sure what would work best for me. Well, quick review. Nah, these are hopeless. Not very comfortable on the head. Not very comfortable at all. The two fold down eyepieces are far enough apart that you can't get binocular view with them. You've got to look through either one or the other, so you might as well just use a single monocular something or other. At least that's at 10x, pretty hopeless. From the set of lenses, the 6x one, the lens just falls out. That's not good. Drop back to the 4x lenses. Yeah, I still can't get binocular vision out of them. So yeah. Oh well, it was worth a try, but these are going back. That's good timing. My coupling relays have arrived, so I can wire these in and hopefully get my lathe up and running again. Right, well, as you can see, I was actually able to make space for those two coupling relays just by shoving the power supplies and e-stop relay across. So that's kind of nice. Let's check it out and see if it works. So spindle start, speed up. Down. All right, we're back in business. I do still need to update my wiring diagram with this. Okay, well that's the last one for that side. Cool. Well, I think that first operation's gone rather well. So now I just need to take the same toolpath, strip out the threading, strip out the boring and coring. Really, it's just the facing, turning, and a chamfer. And we'll be ready to go to the milling machine and put in the wrenching holes. So let's get into it. It's kind of nice that that coring drill gives me a bunch of nice little slugs of steel. I'm sure I'll use them for something. Right, well that's all the lathe work completed. Didn't quite get a perfect match on the outer diameter, and that's probably because I cut my soft jaws for 90 millimeters, which put them right on the edge of cutting into that hole. In fact, going through that hole. I'm now gripping 88 millimeters, and therefore I'm gripping right on that weakest spot there. So they're probably not all three perfectly even, and that's why I ended up with a slight step on each one. Probably should have gone searching for another set of jaws and turned them out to the correct diameter. Oh well. Next step, off to the mill. Well, there we have it, my first ever sort of mini production job. I guess the main thing I have got done here is get that tool changer working, which is a fantastic step forward. You can see how long this has been on the to-do list because the whiteboard marker doesn't even come off properly anymore. I'm super happy to have the lathe tool changer working properly, and now I guess the next thing's going to be making the hubs. Later on the same day this video goes live, I'm going to be doing a live stream for my Patreons and members. Hope to see you there. Thanks for watching.